Okay, welcome back everybody to the 5th Python tutorial in this series. So hopefully if you are watching or attending today, you have seen the first 4 sessions. To recap, we set up our workspace, we parsed a text file into a data dictionary, we computed the wind chill index and the heat index. So if you had any technical difficulties up until this point, hopefully we were able to set up a time to meet or sync up to work through them together. Today we're going to refactor our code into reading, computation, and printing Python modules. And we're going to learn what a module is, as well as a package. So before we begin, I need to review our code of conduct. By joining this Zoom call and participating in this tutorial seminar series, you've agreed to adopt these values and engage in respectful communication only. Any inappropriate remarks will have you removed from the call. The seminar is only an hour long, so please ask questions throughout. And I'll try to address them when I'm able to, if they're relevant to the entire audience. And there'll also be some dedicated time for questions at the end, and some help and support in the chat throughout. So we're going to do our best. But again, it's only an hour long, so that we are able to get everyone up to speed before we keep chugging along. And as always, today's commands are on the website. And I also want to point you to 2 other online learning resources, Stack Overflow and Project Pythia. Okay, so again, we computed wind chill index and heat index. And I had an error last time where the 4th variable was missing a negative sign. So we'll go ahead and fix that together today. And with that, I am going to transition over to my terminal, and you should all open up a terminal as well. Let's see. Okay, so let's revisit where we are. First, we need to move into the directory where all of our work is being stored. So if you've named things the way I have, that's Python_tutorial_22. And you need to activate your Conda environment. With Conda, activate, and then the name of your environment. So often you might come to run a code and it's not working and you're not sure why it's not working, and it's because you forgot to do this small step. So just going to keep reminding every single time, and that you can check that you've installed it or that you've activated it with these parentheses at the beginning of your line. Okay, so I'm going to do an ls to list what I have there. Again, if you're on Windows, I believe it's dir to show what's in the directory. And we have a data folder, and we have 2 files, heat index comp and wind chill comp. There's a lot of similarities between these 2 files, and that's going to be the key objective of today, is to refactor our code to deal with these in a more intelligent way. So the first thing, let's open up one of them and look at it. So let's look at our heat index comp. Okay, we have our columns and types dictionary that we use for our data reading. And then we have this whole block of code under initialize my data variable, read data file. All of this is identical in both of our files. So we'll address that today. And then also down here, when we have our compute heat index function, make sure you've added a negative sign here at the D variable. So it's a negative, positive, positive, 3 negatives. Let me just double check this again. Would hate to be wrong one more time. Okay, scroll down. Yep, and then the last one is negative as well. Okay. Okay, so the first thing we are going to do is deal with the reading of the file. And then you'll also notice that the printing of the file here, this is also something that we are going to turn into a function that we can use in both of our computation files today. Okay, so I am going to go up to the reading file up here, and I am just going to copy all of this right here. So not the first 2 columns and not the function and everything after it. So I'm just going to copy that. I can just use Control-C. You might be able to right click and copy. Different text editors might work slightly differently. And I am going to leave the script. If you made any changes, go ahead and save them. And we are going to create a new file for reading our data. We can do that with touch read data.py. Okay. So again, we use touch to make a file, but that's not the only way that you can do that. When you specify the name of the file that you'd like to edit, if that file doesn't already exist, it'll automatically be generated. Maybe you've noticed that when you type nano and then misspell the file you wanted to open, it automatically generates this file for you. And then if you don't save it, it just deletes it. But touch creates it for you. And you'll see that when you do an ls, read data.py now exists. Let's go into that file. Nano read data.py. And that opens up our familiar text editor here. Okay. And speak up if the font size isn't working for you or anything like that. Okay. So we are going to create our file with the familiar command define and the name of our function. Let's call it read data. And then it has the arguments. We'll pass into it the columns dictionary that you'll specify in each script and the types dictionary. And we're going to introduce keyword arguments here. So instead of just saying types, we're going to say types is set equal to an empty dictionary. So what this does with a keyword argument is it'll default to whatever value it's set to if you did not overwrite it in your function call. So normally if you just call this up, you have to always pass in a columns variable, but you could only pass in a columns variable, and then when it reads the data, everything's still going to be a string at the end of the day. But you could choose to pass in a types dictionary that turns things into your desired data type. Similarly, we're going to have a keyword argument for file name, and that is going to be the path to our file. So in quotes, because this is a string, data, and then wxobs 2017-08-21.text. So again, this means that you do not have to specify the file name every single time, which is convenient for us because we're using the same file, but it means that you'll be able to hypothetically reuse this same function for any data that is similarly formatted and needs to be read in the same way. So you could pick any other day from the same weather station and pass it into this file and just specify it in your function call. And then close your parentheses and add a colon. And then we're going to go ahead and paste everything that we copied from before. And we're going to go in and make sure everything's indented properly and fix that all up. Another note on keyword arguments is that they can be called in any order when you're actually calling up the function, because when you call them up, you have to pass in the name of the keyword argument equal to the value you want it to be set equal to. But for your regular arguments, they are positional and you have to call them in the correct order. So whatever you pass in first is going to be taken as the columns. And whatever you set equal to types or equal to file name is those things. And they can be in any order from each other as long as they're after all of the positional arguments. Okay. Do we now have a duplication of the file name? I'm not exactly sure what you mean by that. Oh, yes. Yeah, we're going to go in here and fix this up. So this read the data file name line is one of the changes we're going to make, because that can now be deleted safely. Okay, so here on the first line of our function, sorry, it's a little hard for me to see my cursor. Okay, at the beginning of this line, we're going to indent 4 spaces for our comment. We also still need to initialize our data dictionary and to go through our columns. That's all the same. These 2 lines, as Frank pointed out, we can delete. You can do that, I believe, with Control X, just like that. And then we are going to go ahead and indent all of these lines as well. 1, 2, 3, 4. Oh, I missed the first one. Okay, so hopefully you have the indenting correct now. So you still have a for block and a with block, and inside of the with block are 2 for blocks and another nested for loop. Okay, and we also need to add a return statement. And we're going to return the value data at the end of this. So go ahead, indent 4 spaces, return data. So that makes it so that the variable data is available to us when we're no longer inside the function call. We're calling the function to get this variable. And this comes into differences between local and global scope and things like that in your Python function. So like you wouldn't be able to call up some of these variables, like I and T would no longer be accessible. They're just used in the loop within the function. But we want data to do the rest of our work. So now we're going to do one more thing before we move forward. And that is, we're going to add a doc string to our function. So to do that, go up to the top of your function. And we are going to add triple quotes here. 1, 2, 3. And also triple quotes to frame it. So the triple quotes work like a comment on a line, except it can span multiple lines, which is great for human readability. And this is commonly done at the beginning of your function to, in plain language, specify what the function does, what the types of your arguments need to be, and what your expected outcome would be, possibly even an example of the use of the function. And then oftentimes when you see documentation for a Python module, the values on the documentation site are just taken from this doc string. And it's good for you, even if that's beyond the scope of what you're hoping to get out of writing functions, to just know what your function does and what you need to pass into it for it to work the way you designed it to. So the first thing we're going to add here is a description of what our function does. Make sure you've indented 4 spaces still. And what this does is it reads data from CU folder weather station data file. And the next piece that you're going to do is the parameters. Yes, also, just to point out, your docstring needs to be the first thing in your function, right after the define line. You can't initialize your data variable, then specify what you're hoping is going to happen, and then continue on. It happens first. Hopefully that feels somewhat intuitive to you. So then in your parameters, we are going to have 3 different lines for columns. The indentation here isn't quite as strict, but we're going to still be consistent. Types. And our third argument, or specifically keyword argument we have, is file name. So now I'm going to go ahead and add some text to each of these. So a dictionary of column names mapping to column indices is what we see in the columns dictionary. So here we've specified the type and what you hope it to be. This also is a dictionary of column names mapping to types to which to convert each data column. And then I can also say like otherwise they will be strings. This is a little bit of a long line, so I'm going to actually add a space here and just do that. And then the file name is the string path. Again, we're specifying the type, pointing to the CU folder weather station data file. So another note on the doc strings with the triple quotes, it lets you define a multiple line string. But what's really nice about that is that you don't have to do these backslash ends all over the place to specify that you're breaking a line. Okay, so now let's go ahead and leave this script, save it, and then we'll do a quick git commit, and then we'll go through and change our existing computation scripts to use this function instead of repeating the code redundantly over there. So I'm going to do a Control X to leave and say yes to save. We did a lot of changes here, so if you accidentally say no, that could set you back a little bit. Okay, so now git add read data.py and then git commit -m, adding a new read data module as our commit message. And then if you want to see this, we can do a git log --1 line. So you can see that our origin main is here at renaming our first script. So we still have to push back to GitHub with the changes we've made to our work. But this is where we are locally. Okay, now go into your script. So Nano, let's start with the windchill script, windchill-conf.py, because we wrote it first. And first, I'm going to take you through the steps to import and use the module we just wrote. So a module essentially being just a .py, a Python script, and one that we are using to import. So I'm going to show you how to do this here, and then I'm going to stop sharing my screen and make the changes over on the heat index comp script, and then we'll meet back together to compare. So the very first thing is at the top of the script, we are going to add the line from read data, import read data. So from the read data module, import the read underscore data function name. So more about this, in Python, you call up functionality from scripts that are outside of your active script, so outside of the Windchill comp script, with the import statement. So again, our read data module is just the name of our script, and that houses the function that we're looking for. You'll see this line at the beginning of almost every Python script, because when you're using other packages, anything that's not just pure Python, you're going to be taking various functions from across the Python community. And we're just doing it right now with something that we built locally to hopefully, demystify, make that process make more sense and seem a little bit less scary. So we keep our columns and types dictionary, but we can go ahead and delete all of these lines here. So I'm going to just delete these. I'm going to go ahead and keep this comment because we still need to read the data file. But what that looks like is going to be so much shorter. It now looks like data equals read data. And then you have to pass in your arguments, which is columns and types equal to types. So again, with the keyword argument, we have to specify the keyword argument types and then the value we're setting it equal to. And we're setting it equal to this types dictionary up here. And we do not have to specify the file name because we're using the same input for that. That is the default when we defined our function. Okay, so I'm going to go ahead and save this. Oh, sorry, not this way. And we can run it to make sure it still works. Okay, that's as expected. Let me clear this so you're not seeing all these lines. And I'm going to stop sharing to give you a second to do this to your heat index function as well, to give you a chance to practice on your own. And if you need help doing that, ask in the chat and we'll all be there to support you. Let me go back to sharing my screen. Okay, the read line function was to read each line of the data file. If you meant what is the line that we're using to read the data, I'll go ahead and paste that in the chat again, but I'm going to show you on the screen in a second. So there's 2 new lines we need to add. So we need to add this import line from read data, import read data. And then we need to add this data equals read data, columns, and types equals types, replacing all of that other code that we have. And this is nice because this function is already pretty long. And it's nice to be able to see the whole script on one page and not have to scroll a bunch. Because then you can it's easier to get lost and forget what's happening. This kind of compartmentalizes things. So you're like, oh, we read the data, and then you can kind of move on. And if you want to go into this, you know where to go to look. Okay, no such file or directory. In what you posted there, it looks like you have 2 backslashes instead of 1. That's possible. We can go back and look at our read data function together. The key error time. Is this when you try to execute the script after you've made these changes? Yes. Okay. Well, let's see if that happens and maybe what is different with your script. We can try to figure that out together. Okay. So let's go ahead and look at our read data module again so people can get another chance. So the file name here, I'll just copy it into the chat so that you can compare it with yours more easily. Also, again, if you are on Windows versus Mac, when to use forward versus backslashes is different. So hopefully that is your correct file. If not, make sure. Another thing I would double check if you can't access your data file is your data paths. So our read data is up here at the top level of our directory. And inside the data is where our file is. If you have your structure organized differently than that, I won't be able to access the file with the exact same path command. Okay, and then again, let's check that our heat index comp works. Okay, it's running for me. As for why there's a syntax error for you, Bill, I'm not sure if I can diagnose that during this session without having to ask you to share your screen with me at a later time, but hopefully I'll show something on my screen that helps you find it. Okay, thanks, Kevin. Okay. Let's do another Git status now that we've changed both of our files. We have 2 unmodified files, so let's go ahead and add them. But you'll also notice that we now have this PyCache directory right here. So PyCache is being listed as untracked. We're going to create a Git Ignore to include this in it. And I'll have to explain what both of these things are right now. So whenever you import a Python command, so we've imported our read_data function, Python recognizes that you have written code for the purpose of calling it potentially multiple times. So the interpreter that compiles your scripts to bytecode and then stores them in a cache, stores them in this cache called PyCache to make your scripts run just a little bit faster whenever you call them up the second time. So as a user, for the most part, this is a convenience that you do not have to worry about. You can ignore this. But every time you change or delete the scripts, they'll recompile and reappear in this folder. But we don't need them to be reflected in our Git repository, upstream or locally. So we're going to go ahead and create what is called a Git Ignore. So we'll do that again with the touch command, touch.gitignore. And we'll go inside of it to make some changes. And each line in your Git Ignore is just the path to the file you don't want. So nothing fancy, just double underscore PyCache, double underscore, and then the backslash because it's a directory. Okay, save this. And now when you add your Git Ignore to your Git, so git add dot git ignore. Now when you do a git log or a git status rather, we have a new file that's been added and you'll no longer see an untracked PyCache file. So let's do a git commit for adding our Git Ignore. Git commit -m and then your message, ignoring PyCache. And now we can go ahead and add both of our other files with a git add -a for all. Oh, doesn't like that. Okay, so I'm just gonna, is it uppercase? Yeah, you can see here it's uppercase or all, not lowercase a. Okay, I'm going to just add a few lines in case you couldn't see that at the bottom of my screen. Git add -a will change it. And now I'll do a clear and another git status. And you can see that both of our files are now changes to be committed. So let's go ahead and commit them. This time our message, I'm going to make mine a refactor scripts to use new module. Okay. So congratulations, we've just refactored our code and removed a redundancy. We still have some repeated code, specifically in the printing blocks of code. We'll look at that. But we have now refactored our code, taken out some duplicate, and showed you how to import it. So hopefully when we do this again, it's a little bit easier. So we're going to create a printing script. I'm going to call it printing. Okay. And then I'm going to go and perhaps copy some of the code again from our different script to give us a good starting place. Let's go into the Windchill. And you can just kind of grab these lines of code here. So we have our read data line, our function, we're calling the function, and then everything after that, the output comparison of data, that is all going to be moved into a separate function. Okay. So now we'll go into printing. And we'll name our function print comparison. And I'll just go ahead and paste everything we just copied before I potentially lose it from my clipboard. So the values that we're going to pass into our printing function is going to be, we have the name of whatever our computed variable is, dates, times, and then we're going to have our original data and our computed data. Okay. We're going to, again, indent for spaces and add a doc string, 1, 2, 3, 4. I'll actually go in and edit what this doc string looks like after we have fixed up this function to do what we want it to. Okay, we can perhaps delete this line here. An indent for spaces. Indent for spaces. Oh, sorry, I wasn't aligned down. I'll just start out by indenting everything to now be in a function space. And then we'll go in and change the variable names to be appropriate. So the first thing we're going to change is going to be on our second line of the function. We're going to use F strings again, if you remember those. So print, open parentheses, a lowercase f, and then open close your string. And what we're going to do is change where we have wind chill, which we have twice here. Open close your curly brackets to be input that you're putting into your string. And we're going to call it name.upper. So that takes whatever your name input is, turns it into all uppercase letters. And then we're going to also do this colon greater than 9 to specify that we want it to be the correct number of characters. And we're going to go ahead and do that again to this second value of wind chill. Name.upper. Colon greater than 9. Okay. And now in our for loop down here, see where's where are we? Okay. These values here, as you can expect, are not what we want anymore. So let's just go ahead and delete everything that we've put into the zip data variable. So we're not going to have to pull date and time out of the data dictionary right here because we're not passing the data dictionary into this function. We're going to be passing the values, dates, and times. So we're going to say for date, for time, for original data, and comp. Oh, wait, sorry. Actually gonna say zip data, we're zipping dates, times, original data, and computed data. And then we're gonna say for date, time, computed, and original in our zip data. Our difference is no longer specific to wind chill. It's just going to be our original minus our computed. And then down here, we got to change all of the WC datas to original and the estimates to compute. And this is just simply a difference. Okay, and now we will add a doc string here as well. We'll go up, indent 4 spaces, and describe what your function's doing. Here it is print, it prints a comparison of 2 time series, original and computed, of data. And we have parameters. We have a name. We have dates. I think this one I had an extra space there. Times. And then our 2 types of data are also parameters. So in this function, everything is an argument. Everything needs to be passed into it. There are no keyword arguments that are going to assume a value if you choose not to pass it. So name, a string name for the data being compared. And then you can add in parentheses that we have a limitation on this, which is 9 characters that will be displayed. I'll say display limited to 9 characters. For dates is a list of strings representing the dates for each data. Let's get that period just for consistency. And then times is a list of strings representing the time of day for each data. Yeah, so your doc strings are better than just a long multi-line comment in that they are easier to read. And then Sphinx is a popular tool for taking documentation on GitHub and building the documentation for it, and it will strip your doc strings for this. And also, if you just use your help function, which is a built-in Python function, it'll display the doc string to the user for what they have to do. You do not have to use a doc string instead of comments, but it's definitely, it looks nicer, it's more common, you'll be more equipped to understand and know how to read other functions and how their doc strings are formatted. And so now we have 2 more parameters we need to describe in our doc string. So both of these are going to be a list of data. So we have a list of original data, and that's floats, and a list of computed data, also floats. Okay. Okay, I'm missing just 1 space here before that. So this function, much shorter, but yet has much more input arguments. And we're going to go ahead and edit both of our scripts to actually use this. We don't need any value from this to be available outside of the function. This function is performing a task of printing our data. It's not generating a variable for us, so you don't need to return your zips data or anything like that. You can still choose to add a return statement at the end of your function. And let's go ahead and edit our other data to use this. Okay. I'm going to leave this, save it. Maybe do a quick git add to show that we've done this. Git add printing.py, git commit, adding a printing module. Okay, and we'll go ahead and edit both of our scripts. So again, I will show you how to do this for the wind chill script, and then you can go ahead and independently repeat the process for the heat index script. So from printing, import print comparison. So you'll notice we do our import statements at the beginning of our file. So the way Python reads your script is at first, it will come across this and make sure that it can access this function, but it's not actually going to read it yet. So it's going to make sure that it has access to the things you're asking it to. It's going to go and do all this work. And then when you actually call up the function, it's going to go into the script. And then read the function that you've imported. Okay, so again, our reading the data should look the same. Our function and calling up our function is going to look the same. But we can go ahead and delete these lines at the end, and we're going to replace them with a one line function, or a one line call. So we're going to delete 1, 2, 3, 4, 5, 6, 7, 8 lines that we're replacing with 1. And we're just going to call up our function, print comparison. Okay, so remember the first argument is the name. And what that is going to look like is wind chill. And it's a string. You need to put it in parentheses or in quotes like this. You do not have to capitalize it because we specified that we're going to capitalize it. And then we pass in dates, which we get from our data dictionary. Same thing for time we're getting from our dictionary. Our original data is in our dictionary. And the last argument, again, these are positional. You have to enter them in the order that you want for the function to function as properly. You're going to add the wind chill variable that we just specified in like the line before we appended that list. Okay. Let's save this, double check that it still works, and then move on to heat index. Okay, so I'm going to run the function. Oh, yes, I have a spelling error there or a typo. I'm going to go in and fix that. So I accidentally called my dictionary date instead of data. Save this and run it again. Okay. If you had a similar issue, let me scroll back up. So sometimes when you get error messages, it can be kind of overwhelming, but you'll see that this was very helpful. So I'm just going to show you how to maybe read an error message. It's telling me that I have a name error. It's even suggesting what I might have gotten wrong, and it's showing me the line where I got it wrong. So it's very easy for me to spot this change right here. It's not as easy all of the time to notice where you made a typo, but hopefully this is helpful. And I also wanted to scroll all the way up so we could see the header from our printing anyways. So you'll see that this is still formatted the way we'd expect it to. And hopefully you're able to track down your syntax errors as well. Okay. Now I'm going to give you a chance to do this to your heat index function. So I will stop sharing my screen and we'll go do that work independently, and then we'll share my screen again. Okay, so now if you look at your heat index comp.py file, you should have two import statements. And at the end, your output comparison of data should be one line calling up your print comparison data. Hopefully everyone was able to get this. Let's go and run it and make sure it works. Okay, no syntax errors this time. And let's go ahead and do a git commit. So a git add, let's do a git status first. And we'll do a git add for all. Remember the capital A, and a git commit message. Reading the printing module. Okay. So there's one last change I'd like to make, but I think we don't have time today, is take out our concept of the data analysis and also pull those functions into a separate computation script that holds both of those. So we'll do that next time. Turn them into functions that use doc strings and that are imported, and really clean up our Python scripts that way as well. But we'll do that at the beginning of our next session. And we'll then package our data and package our script, package our modules, push it all back up to GitHub again, and begin showing you what it's like to actually use and import Python packages. We'll introduce the math Python package, which is built into Python. So we still don't have to worry about environment management and things like that, but we will use packages that we did not write ourselves to kind of build up to using the whole Python ecosystem. And I'm going to stop the recording now and then take some questions that people might have. So thanks again for coming, and we'll see you in 2 weeks.